All right, so we're going to move on to our section, which is completing the square or complete the square. And there's two topics in this section. There's using the square root property to solve an equation, and then also this method of completing the square. So we're going to go over both, okay? We're going to go over the square root property first. And this is something that you may have seen before. Basically, what the square root property says is that if you have a number that's squared, okay, and you know what it equals, then you can get rid of that square by taking the square root, okay? So basically what we're doing is if we have a squared equals b, we're taking the square root of both sides so that this square and this square root will cancel, okay? But when we take the square root, we have to remember to use our plus or minus sign because we don't know if this number would have been positive or negative, right, when we're dealing with squared numbers. So we always have to account for that when we're solving to put in our plus or minus so that we get both possible answers, okay? So here's our strategy. We're going to isolate the term or the quantity that's being squared. So we don't want anything on the side of the equation that we're working with unless it's the thing that has the square on it, right? And then we divide off any coefficient, and then we take the square root, okay? Again, don't forget your plus or minus. A lot of people miss these problems because they're missing answers because they forgot to do the plus or minus. They just did a positive square root, okay? So let's look at some examples. First one here, it says solve, well, it just says solve the quadratic equation, but we're going to use the square root property. So, excuse me, notice here, the thing with the squared exponent is this x. Okay, the square is not being applied to the 2, it's not being applied to the 50. So I want to get just this x squared all by itself. And I start by getting rid of the 50. So I'm going to add 50 to both sides. So I have 2x squared is equal to 50. And then again, that x squared is not being applied to the 2, so I want to get rid of it by dividing it off. So I have x squared is equal to 25. Now that I have the squared item all by itself, now I can use the square root property that says I can just take the square root of both sides, okay? So I'm going to take the square root of this side so that my square and my square root cancel, but when I do that, I have to do plus or minus the square root on the right side, okay? So my square and my square root cancel, so I'm left with x is equal to plus or minus, and then we know the square root of 25 is 5. Okay, so that means our solutions are positive 5 and negative 5. And you can always check your answer by taking either positive 5 or negative 5 and plugging it back into the original. Okay, if when you plug it back in, you get a true statement, you know you did it correctly. Okay, let's look at another one. Let's look at this one over here. Same idea. The only thing being squared here is that little x. So I want to get that little x all by itself. So I'm going to start by moving my 12 by adding 12 to both sides. So I have 98x squared is equal to 392. And then I need to get rid of this 98 because it does not have the squared on it. It's only on the x. So I divide off the 98, which gives me x squared is equal to 4. And then, just like our last one, now that we have the squared item all by itself, we can take the square root of both sides. Don't forget your plus or minus on the right-hand side, okay? So this gives us x is equal to plus or minus 2. Okay. Now in Newton, I don't think they'll let you enter your answers with a plus or minus sign. So if you were to get something like this, make sure you enter it. I think it just says to enter like the numbers separated by a comma. Okay, something like that. So be sure you pay attention to the instructions on how they want it entered because I don't think you can use the symbol. Okay. All right. So let's look at another one. Same idea, the only difference here is notice there's more than just the x being squared. Everything in this quantity is being squared. So the squared thing, right, is already isolated. So I can go straight into taking the square root of both sides. That way my square and my square root will cancel. Don't forget your plus or minus on the right-hand side. So on the left, once my square and my square root cancel, I'm left with just x plus 5, and that's going to be equal to plus or minus 7, which is the square root of 49. Okay. Notice once I simplified the square root, I don't need the square root symbol anymore, right? I noticed that on some of y'all's worksheets. Once you simplify the square root, that symbol's gone. Okay. All right, but I'm still not solved because I'm solving for x, and right now x is not isolated. Okay, so I need to move this 5 to the other side. I'm sorry, minus 5. So I end up with x is equal to negative 5 plus or minus 7. Now, this plus or minus gives us two separate answers. And notice 5 and 7, those are just regular digits, right? We can add those numbers together. So that means I get negative 5 plus 7, and I get negative 5 minus 7. So I just need to work out what those two solutions are, right? Negative 5 plus 7 gives me a 2, and negative 5 minus 7 gives me a negative 12. Okay, maybe not too bad. All right, so there are a couple at the bottom of the page here for you to try. So go ahead and take a minute to pause the video and work out number 1. All right, so on the first one, we first need to move our 35 to the other side. So we get negative x squared equals negative 16. And notice here, we're still not completely isolated because we have a negative in front of the x squared. So I need to divide that off by dividing off a negative 1. Then when I get x squared equals 16, then I can go ahead and take the square root of both sides. Don't forget your plus or minus. So number 1, we should get x equals positive 4 or negative 4. Okay. On number 2, our squared thing is already isolated. So we go ahead and take the square root on both sides. Don't forget your plus or minus on the right. And our square and our square root cancel. So we have x minus 7 on the left and plus or minus 8 on the right. Then we need to go ahead and move our 7 to the other side. And because these are regular numbers that we can combine, we want to go ahead and work it out. So 7 plus or minus 8. 7 plus 8 gives me 15. 7 minus 8 gives me a negative 1. Okay? All right, so that is how we effectively use the square root property. Now what I want to do is I want to move on and look at how we use the completing the square method. Okay? Completing the square method. So I have 4 examples that I want to show you, and then you'll be able to try it. So basically, this one's a little bit different. You know, with solving by factoring, we want everything in standard form before we started factoring. When we're completing the square, we actually want our equation to look like this, meaning we have our 2x terms on the same side, but if we have a constant term, we want to move it to the other side. Okay, so here's our strategy step by step, and I'm just going to read through it and then we'll do some examples which will help. Okay, so first of all, anytime that we are going to be doing completing the square, our leading coefficient must be 1. Okay, it doesn't matter if you do all the other steps. If your leading coefficient is not 1, it's not going to work. Okay, so we start by dividing off any leading coefficient that there might be, unless there's not one. If it looks like this, then obviously we're fine. But if there's a number in front of that x squared, we have to get rid of it. Okay, so we divide it off. Then we move our constant term to the other side of the equal sign so that you have only the x terms on one side. So that's what I have up here. Notice we only have the x terms. The leading coefficient is a 1. I'm assuming we've already, divided it off. Now we're going to move on to actually completing the square. So what that looks like is we're going to take half of the x term coefficient. So that would be this guy, okay? Whatever's in front of this x, that's what we're going to take half of, okay? So we're going to take half of b, okay? And whatever that is, we're going to square it and add it to both sides, okay? And then when we do that, we'll be able to solve using the square root property, and I'll show you that when we get there, okay? Now, I want to point out that it says here, assignments from this section must be worked using completing the square. Okay, the reason that is I know that anytime you have a quadratic equation, some of you know how to do the quadratic formula. Some of these may be factorable, but I want to ensure that you're learning this actual method of completing the square. So some of the assignments that have been assigned may not be the very, very end result answer. It may be the answer you get once you've gotten to a certain point in the completing the square process. So if you don't use completing the square to work out your homework exercises, you probably won't get the right answer. So be sure that you're using the method that I'm showing in this lecture video to work out your assignments, okay? All right, so let's jump in. Here we go. So on this first one, the first thing I want to do is make sure my leading coefficient is a 1. And here it is. So yay, check. Okay, the next thing I want to do is make sure my constant term is moved to the other side. So I'm going to go ahead and move it over. So I have x squared plus 12x equals, it will now be a positive 28, right? Because we move it over by adding. All right, so now that I have just my x terms on this side, I want to go ahead and take half my middle term, okay? Half my middle term's coefficient. So I'm going to take half of 12, okay? And I write it out like that because at some point we may have fractions, so it's nice to get used to seeing it as half of means half times, right? We all know that half of 12 is 6. Okay, so I'm going to go ahead and just put 2 lines under this, and I'll show you why here in a minute. Now, once we take half of our x term coefficient, this is what we're going to square and add to both sides. Okay, so we already have our x squared and our 12x, and now we're going to be adding in our 6 squared. Okay, and if we do it on one side, we got to do it on the other side. Okay, all right. So the reason that we're adding this in is there's actually some method to our madness here. If you square half of the x coefficient and add it to this side, this is going to create a perfect squared trinomial. And what I mean by that is when we simplify this side, we get x squared plus 12x plus 36. And this is going to be something that factors perfectly. So let me show you. Here our sum would be 12. Right? And our product would be our leading coefficient 1 times our constant term 36. So I need something that multiplies to 36 that combines to 12, which would be 6 and 6, right? 6 times 6. And I can use the shortcut always, right? Because we always ensure that our leading coefficient is a 1. So yay for the shortcut. All right. So what this tells me is that this factors, whoops, I broke my lid. This factors into x plus 6 times x plus 6. Okay, so this is what I mean by it creates a perfect square trinomial, is when we take half that x term coefficient, whatever it may be, and we square it and we add it over here, this will always factor into a quantity squared. Okay, on the other side, we just combine our numbers. So this gives me 28 plus 36. 28 and 36 is 64, right? So let me go ahead and write that in. And now this is something that I can solve using the square root property that we just did, okay? So notice my squared item is already isolated, so I just take the square root of both sides. So square root of x plus 6 squared equals, don't forget your plus or minus, square root of 64. My square and my square root will cancel. So I'm left with x plus 6 is equal to plus or minus 8. Okay, and then I need to go ahead and solve for x by moving my 6 to the other side. So I subtract 6. So x is equal to negative 6 plus or minus 8. Okay, so notice here, these are two numbers that are like terms, so I can go ahead and combine them. So negative 6 plus 8 gives me a positive 2, and negative 6 minus 8 gives me a negative 14. Okay, so that is my solution. All right, so let's quickly go back over it, and then I want to show you a shortcut that will save you a lot of time. So first off, make sure our leading coefficient is a 1, right? And we move our constant to the other side because we don't need it right now. We're trying to create a perfect squared quantity on this side. And the way that we do that is by taking half of this x term coefficient. So we took half of 12, we got 6, right? We're going to take that 6 and square it and add it to both sides, okay? When we do that, that creates this polynomial here, this trinomial, that will factor into a perfectly squared quantity, okay? Once we have a perfectly squared quantity and we've simplified the numbers on the right, then we just solve by the square root property, okay? Now we're going to do more, but I want to show you a shortcut, okay? And I'm going to work another one, working it all the way out, but I just want to show you the shortcut now so you can be looking for it. Notice, whenever we took half of this middle term, we got 6, right? And notice, this is a positive 6, right? Because we took half of positive 12, we got a positive 6. notice what we ended up with over here inside our squared quantity was an x plus 6. Now this will always be true, always, always, always be true, that whatever you get when you take half the middle term, that number will be what's inside this squared quantity. So in theory, you could actually skip all this entire step, and go straight from knowing that that's 6 to writing the quantity x plus 6 squared. The only thing you do have to remember is to go ahead and square that 6 and still add it to this side. Otherwise, this number won't be correct. Okay, so let's look at another one, and then I'll point out the shortcut on it as well so you can see it again. Okay, so first step when we're completing the square, make sure our leading coefficient is a 1. Here it's not, it's a 2. So I want to start by dividing off that 2 from every single term. Okay, so that's going to leave me with x squared minus 6x plus 5 equals 0. Right? And then I don't want my constant term on the same side. I only need my x terms. So I'm going to move my 5 to the other side. So I have x squared minus 6x equals 5. Right? And now that I only have my x terms on this side, I can go ahead and start completing the square. So I'm going to look at my x term coefficient, which is -6, and I'm going to take half of it. So when I take half of -6, I'm going to get -3. So -3 is what I'm going to square and add to both sides. So on the left-hand side, I have x squared minus 6x plus -3 squared is equal to 5 plus -3 squared. So I'm just squaring it and adding it to both sides. Okay. All right. Now I'm going to go ahead and simplify this. So I end up with x squared minus 6x plus 9. And on the other side, I have 5 plus 9. Okay, notice this is a perfect square trinomial, because if we look at our sum product chart, I would need something that multiplies to a positive 9 that I can combine to get a -6, right? Which would have to be -3 and -3, right? -3 and -3. And we can use the shortcut always because our leading coefficient is a 1. Okay, so we know this factors into x minus 3 times x minus 3, which is equal to 14 when I combine my 5 and my 9, right? Or we can see this as x minus 3 quantity squared equals 14. Okay. Oh, no, it doesn't. Oops, I made a boo-boo. Are you ready to see my boo-boo? Go back up here. When we first move our 5 over to the other side, we move that by subtracting, and I have a positive. My bad. So this should be equal to a -5. Sorry. When we go back, we move that constant term over, it's going to make it a negative. So let me come down here and fix that. So this should be a -5. This should be a -5. So when I combine -5 and 9, that should equal a 4. Sorry about that. I got so excited, guys. All right, so now that I have a squared something equals a number, now I can solve this by taking the square root of both sides. Okay, so I have the square root of x minus 3 quantity squared is equal to plus or minus the square root of 4. Okay, so my square and my square root cancel. So I get x, oh my goodness with my signs. X minus 3 is equal to plus or minus 2. And then the last thing I do is move my 3 over by adding. So I have x is equal to 3 plus or minus 2. Because these are like terms, I can go ahead and combine them. So I have x is equal to 3 plus 2, which is 5, or 3 minus 2, which is 1. So we get 5 or 1. Okay, so this is the whole process. This is it. This is it. This is what we're doing. Okay, but I do want to point out the shortcut. So those of you who can remember the shortcut, it'll save you a little bit of time. Back up here, when we took half of the middle term, so half of -6, that gave us -3. And notice down here, we ended up with x minus 3 as our squared quantity. Okay, so if you can remember that, as soon as you take half of the middle term and get -3, you can just take that -3, stick it in this squared quantity. All you have to do is remember to square it and add it to this side, so we end up with the right number on the right hand side. Okay, so I want to work a couple more, but I'm going to use the shortcut on these other examples. Okay, so I'm not going to be squaring it on the left hand side and working out this whole factorization. I'm going to go straight from this highlighted number down to my squared quantity so that y'all can see what that looks like using the shortcut. Okay, if you don't like the shortcut, you can of course always work it out completely using this method. Okay, so on the next page, up at the top, we have -x² minus 3x plus 1 equals 0. First thing we want to do is make sure our leading coefficient is a +1. So I'm going to divide off this negative by dividing every single term by a -1. So this gives me a +x² plus 3x minus 1 equals 0. Then I need to make sure my constant term is moved to the other side because I don't need it to complete the square. So I'm going to add 1 to both sides, which gives me x² plus 3x equals +1. Okay, and now I'm going to go straight into completing the square because I have only my x terms over here, which is what I want. So I look at my x term coefficient, which here is 3, and I'm going to take half of 3. Now half of 3 is 1.5, right? But I don't want to write it as a decimal. I want to leave it as a fraction. Okay, so when I take half of 3, I can think about multiplying fractions. This is like 3/1. So if I multiply straight across, I'm going to get 3 halves. Okay, now that is what I got when I took half my middle term. So that is going to be, I'm just going to say, I'm going to use the shortcut here. That is what I'm going to get when I get my factored quantity. So I know this is going to factor into x minus 3/2 squared. Okay. Now, it's fine to use the shortcut on the left-hand side, but I still have to square this and add it to my right-hand side. So on my right-hand side right now, I just have a 1, and I need to add 3/2 squared to that side. Okay, so I'm going to have to do a little bit of simplifying here. Okay, first of all, I need to square this, which is going to give me 9/4. And then in order to add 9/4 to 1, I need a common denominator, right? So I'm going to write this as 1/1. My common denominator would be a 4, right, in order to combine these. So I need to multiply on top and bottom here by 4. So that would give me 4/4. Go ahead and write in the rest of my problem. Okay, so when I combine these, I now have x minus 3/2 quantity squared equals 13/4. Okay, so notice what ended up in my squared quantity here is exactly what I got when I took half my middle term. Okay, and then I had to square it and add it to this side so that this number is correct. Now that I have my squared thing, right, my squared item isolated, I can go ahead and take the square root of both sides. So square root of this side, x minus 3/2 squared equals plus or minus, don't forget your plus or minus, the square root of 13/4. Now on this side, my square and my square root will cancel. So I just have x minus 3/2 is equal to plus or minus. Now the square root of 13 doesn't simplify, right? But the square root of 4 I can simplify because the square root of 4 is 2. So I'm going to go ahead and just simplify the bottom of that fraction. And then to get x by itself, the only thing I have left to do is to move this negative 3/2 over to the other side. Okay, so let me write that over here. So I have x is equal to, when I move this 3/2 over, I'm going to do that by adding. So it's going to be positive 3/2 plus or minus the square root of 13/2. And I can't combine these. I could write it as one big fraction if I wanted to. I could write 3 plus or minus the square root of 13 all over 2, but I can't combine the 3 and the 13, right? Because this one's stuck under the square root. So this is as simplified as my answer gets. Okay. All right, let me look at one more and then I will have y'all try some. So first thing we want to do is make sure it's in standard form. So notice here I have an x term randomly on the right hand side. I want to move it back over to the left. So I'm going to subtract 6x. So I have 2x squared plus 2x minus 3 equals 0. And then I don't need this 3, so I'm going to move it over to the right. So I have 2x squared plus 2x equals 3. Okay. All right, so I have my two x terms on the same side, but I'm still not ready to complete the square yet because, why? Because my leading coefficient's not 1. Has to be 1. So I'm going to go ahead and divide off that coefficient. So now I have x squared plus 1x equals 3/2. Okay. Okay. Now that I have just my x terms on this side and my leading coefficient is a 1, I can go ahead and start completing the square. So I look at the coefficient of my x term and I'm going to take half of it. So when I take half of 1, I get a half, right? So a half is what I would square and add to both sides, right? But I'm going to go ahead and use the shortcut so that I don't have to do some product chart with fractions. So the shortcut tells me that whatever I get when I take half the middle term, that's what's going to show up inside my squared quantity. So I know that this is going to factor into x minus 1/2 squared, right? I'm just going to highlight. I'm sorry, not minus, because this is a positive half, so it's going to be x plus half. Okay, but I do need to go ahead and square that half and add it to the right hand side so that I get the correct number over here. So the number that's already over here is the 3/2, right? And then I want to add in my 1/2 squared. Okay, so this gives me 3/2 plus 1/2 squared is 1/4. Okay. Now I need a common denominator in order to combine these two fractions. So 3/2 and 1/4, my common denominator would have to be 4. So I'm going to multiply this one on top and bottom by 2. Okay, and I'm just going to write it out here. So that would give me 6/4 plus 1/4. Oh my goodness, my lead is breaking like crazy. There we go. Okay, so now I can combine these. So on the left-hand side, I still have my squared quantity, x plus 1/2 squared, is equal to, when I combine 6/4 and 1/4, I get 7/4. And now I have that squared item that I can now solve and get rid of that square by doing the square root. So I'm going to take the square root of this side, x plus 1/2 squared, so that my square and my square root cancel. On the the right-hand side, I need to take plus or minus the square root of 7/4. Okay, so on the left, now all I have is x plus 1/2. On the right, I have plus or minus square root of 7 does not simplify, so we're going to leave that as square root of 7 on top. But the bottom, square root of 4, does simplify to a 2. Okay, and the last thing I need to do is move this 1/2 to the other side. And I'm sorry, I kind of ran out of space here, so I'm going to squeeze it in here. So x is equal to, when I move that 1/2 across the equal sign, I'm going to do that by subtracting. So it becomes negative 1/2 plus or minus the square root of 7 over 2. And we leave it like that. Okay, even though these have the same denominator, I can't combine the tops because one's under a square root and one's like that. So I'm just going to leave it written like this. Okay, now remember, in this section, they may ask you to select your answer based on a step within here, right? They may ask you to enter this step as your answer or enter this step as your answer. So make sure that you are working it out in this order, okay? So there are 2 for you to try, and go ahead and pause the video and work through those. And then once you've done those, you can go ahead and play the video to check yourself, okay? All right, so on number 1, we start by moving our constant term to the right-hand side, and that gets our x terms on one side and our constant on the other. Our leading coefficient is already 1, so we can go straight into completing the square. We take half of that middle term, right? So half of -2 gives us a -1. So I'm going to use the shortcut to go straight into this factored quantity. So I know using the shortcut, whatever I get when I take half that x term coefficient, that's what's going to show up in here. So I get x minus 1 inside my squared quantity, and I still have to take that -1 and square it and add it to the right-hand side. When I square my -1, it makes it positive. I combine that with 6, which gives me 7. Okay, then I can get rid of that square by square rooting both sides. Don't forget your plus or minus. Okay, once I take my plus or minus on the left, my square root, my squared quantity is gone. So I have x minus 1 equals the square root plus or minus the square root is 7. And then I just move my 1 over by adding. So our solution to number 1 should be 1 plus or minus the square root of 7. Okay, again in Newton, I'm not sure if it allows you to use this plus or minus sign. So if you are entering your final answer or selecting your final answer, it's probably going to be like 1 plus the square root of 7, comma, 1 minus the square root of 7. They'll probably have you write out both answers. Okay, if you have questions on that, just let me know. All right, number 2, I start by getting rid of that leading coefficient because it has to be 1, right? It has to be 1 so we can use this shortcut in here. So I divide off 9 from everything. When I divide everything by 9, I'm left with x squared plus 1/3 x equals 2/9. Okay, then I can go ahead and take half of my x term coefficient. So half of 1/3 gives me 1/6. I'm going to use my shortcut so I know that a positive 1/6 is what's going to be in my squared quantity, but I still have to take that 1/6, square it, and add it to the right-hand side. Okay, when I square 1/6, I get 1/36, and I need to combine that with 2/9. So my common denominator between 2/9 and 1/36 would be 36. So I just multiplied on top and bottom here by 4 so that I could get 8/36. And now that they have the same denominator, I can combine the top. So 8 and 1 gives me 9/36. And now that my squared item is isolated, I can go ahead and take the square root of both sides. Don't forget your plus or minus. Okay, so I get x plus 1/6 equals plus or minus. Now in this case, the top and the bottom completely simplified. Square root of 9 is 3, square root of 36 is 6. Okay, don't forget that plus or minus though. And then I move my 1/6 to the other side by subtracting. So if it's positive, when I move it over, it's a -1/6 plus or minus 3/6. And they already have the same denominator. So that's super helpful, right? So -1 plus 3 gives me 2/6. -1 minus 3 gives me -4/6. Getting a lisp here. 2/6 and -4/6. Okay, and then the last thing I have to do is just make sure both of those are reduced. So the first one reduces to 1/3. The second answer reduces to -2/3. Okay, all right, so that is the end of your completing the square assignment. So you should now be able to do completing the square or complete the square. I'm not sure how it's listed in Newton. You should now be able to do that assignment. Where's my first page? There it is, complete the square. You should now be able to do the complete the square assignment as well as the worksheet. There's a worksheet that goes with this assignment called completing the square. So make sure you get both of those done. If you have any questions, just let me know.